In section 3.3, we're going to look at the addition and the subtraction principles. So the addition principle just says if you have a finite set, and you can decompose it into a union of different sets, where no two sets of those two sets overlap, right? So the intersection of any two sets is always empty set, as long as they're not the same set as each other. As long as that is true, then the cardinality of your overall set is just equal to the sum of the cardinalities of the individual sets. So when you take your set and you split it up into these subsets that are non-overlapping, that's also called a partition. So you might see that being used. So as long as I can split up my sets into a partition, so I don't have any overlap, then I can just find the number of each of the elements in each of those individual sets, and I add them together, and that gives me the number of elements in the entire set. So we actually saw that in one of the examples in the previous video, so I encourage you to go back and see if you can figure out which example that was. And then the subtraction principle says that if you have a subset of a finite set, then the cardinality of the complement is just equal to the cardinality of the entire set minus the cardinality of x, right? So this is actually just an application of the addition principle. So I know that x union x complement is going to give me the entire set. And I know that x intersect x complement is the empty set. So therefore, by this subtraction principle, we should get that the cardinality of x plus the cardinality of x complement is equal to the cardinality of that universal set, which means that the cardinality of the universal set minus the cardinality of x gives you that cardinality of the complement. So that's all that we're showing here in this subtraction principle. But again, this is a principle that we've already used in the previous video. So again, go back, see if you can figure out where we use that, and we'll see various more examples of using these principles. So let's look at an example here. We want to know how many even 5-digit numbers there are where the digit 6 appears exactly once. All right, so let's think about how to think about this. So I'm looking at 5-digit numbers. And I know that there is a 6 somewhere, but I don't know where it is. But because that 6 appears exactly once, I can break this up into categories based on where the 6 appears. So that 6 is either in the first spot, or the second spot, or the third spot, or the fourth spot, or the fifth spot. So I know that there can't be any overlap between these options because there is only one 6, so no overlap here. So I can use my addition principle. So if I figure out how many options there are for each of these, then I can just add those together because there's no overlap. So let's think about how many options I have for the other spots. So I'm going to write the options down below here, and I'm actually going to write the digit up there, right? Because that's not the 6 options, it's actually the number 6. So really there was only one option. It had to be a 6 in each of those cases. And now if I have a 6, then the next digit can be any of my other digits. So there's 9 digits left. And then it doesn't say anything else about that other digits can't repeat. So I still have 9 digits, right? It could be either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Just kidding, it can't be 6. So then I get those 9 options. And same thing here and here. But then I have to remember it has to be an even number. So if it's an even number, it has to end in 0 or 2 or 4, not 6 because there's only one 6, or 8. So then there's only 4 options there. So here I get 9 cubed times 4 for these options. Below, here we have to be careful, right? This first digit of a 5-digit number can't be 0. So really there's only 8 options. But then I have 9 and 9 and 4. Same thing, 8, 9, 9, 4. 8994. So each of these is 8 times 9 squared times 4. And finally, for each of these options, oops, sorry, that's still 8, and 9 and 9, and then I have that one. So this one's 8 times 9 cubed. Because I already have that 6 there, which makes it even. So overall, my total number of options using that addition principle is just the sum of these numbers. So we really have to think about ways we can break these down into acceptable cases in order to analyze them. All right, let's look at one more example here. How many integers are there between 1 and 1,000 that are not divisible by 3? So how many are not divisible by 3? So I can start thinking about the ones that are not divisible by 3. I notice that every third one is divisible by 3. So it looks like about 2/3 of them are going to be not divisible by 3. Right, but we have to be careful when we get towards the end. So that's one way we could think about it, is to try to just list them all off, and then we get 2 for every 3, so we take 2/3 of 1,000. Right, but that's not actually an integer, so we have to be careful about how we're going to round correctly. But maybe instead I should think about the complement of this set, and I should think about how many integers between 1 and 1,000 are divisible by 3. So if I'm thinking about the ones that are divisible, then I'm going to have 3, which is 3 times 1, 6, which is 3 times 2, 9, which is 3 times 3, 12, which is 3 times 4, right? And then I go all the way down until the last one, which is divisible by 3, which is 999, which is 3 times 333. I did not write a 3 there. Let's fix that. So this is kind of nice because they're naturally counted for us. 1, 2, 3, 4, up to 333. So there are 333 that are divisible by 3. There's 1,000 total. So my entire set is 1,000. Inside that set, I have 333 that are divisible by 3. And so I have 1,000 minus 333 that are not divisible by 3. So that's my 1,000 minus 333. So that means I have 667 not divisible by 3. So this is an example where we used that subtraction principle, so it was easier to calculate the complement of that set, so we did that instead. So here's a question for you guys to think about. How many integers between 1 and 9,999 have no repeated digits, and how many have at least one repeated digit? So see if you can think about a good way to break this problem down so that we can solve it. And then we'll talk about that in class.